Hello everyone. On behalf of SolidCAD, I would like to welcome you all to today's webinar, which is about the workflow between Plant 3D and Advanced Steel. Thank you very much for registering, and it's a pleasure to have you all here. In today's webinar, we will show you Plant 3D and Advanced Steel products, mainly focusing on the workflow between these two products. We'll make sure to highlight the best practices, do's and don'ts, tips and techniques so that you can work with these products without any hiccups. Here's the agenda for the webinar. We will start with brief introductions. My name is Junaid and I'm a technical consultant for Autodesk Plant and Manufacturing Solutions at SolidCAD. With me joining in this webinar as a panelist is my colleague Hung. Hung is a technical consultant for Autodesk Manufacturing Solutions. In only a few minutes, he will get into action and will show you the advanced steel side of things in this webinar. Also, my sales colleague Syed Rizvi is here as a panelist in this webinar. For the next few seconds, I would like to hand it over to Syed, who is going to briefly introduce SolidCAD. Over to you, Syed.
Thank you, Junaid. Hello, everyone. Welcome to our webinar. My name is Syed Rizvi. I'm the product manager for the plant solution at SolidCAD. For the last 25 years, SolidCAD has operated as an Autodesk reseller in Ontario, but today we are the only platinum partner, Autodesk Platinum partner in Canada. We provide expert support, broad range of professional services, and also help the customer into day-to-day and their help as well. SolidCAD specializes in multiple technologies in multiple industries like architecture, engineering, construction, civil infrastructure, and manufacturing. We employ the largest team of industry technologists across the Canada, all time zone, and in both English and French. We believe in providing our clients the solution they need to maximize on the return of the technology investment. And that's it from now. I won't bore you much with this. I will hand it over to Junaid and Hung to show you the live demo of the workflow. Thanks, and over to you, Junaid.
Thank you, Syed. Let's start the live demo. Please be informed that you're welcome to ask questions in this webinar. We'll be more than happy to take a look at the questions in the end, as long as the time permits. Duration of the webinar is 30 minutes, so just in case we run out of time, we will get in touch through emails with all those who ask questions and try our best to provide you with the answers to your questions. First, I have a quick poll question for all the attendees, and you'll have about 10 seconds to provide your response. And you should see this question on your screen right now. Okay. Well, it's good to see that majority of the attendees are already using Plant 3D and Advanced Steel. I've received the responses. All right, so let's start. Here in my machine, I have loaded an example project in the Project Manager, and this is the project I will be using for today's webinar. I have some drawings already created here. So if I expand the Plant 3D drawings folder, I have a subfolder structure that I will be using for storing different kind of files. If I expand the steel structure folder, I have the structures drawing. So let's open this drawing for a second. And I would like to mention that the structure drawing that you're currently looking at has been created using the Plant 3D structure tools. I would also like to mention that I have attached this structure drawing into my equipment drawing as an extra because I wanted to use this as a reference to start placing my equipment. And in the next steps, I would like to attach the equipment drawing and the structure drawing both into my piping drawing to start placing my pipe runs and pipe supports. Let's go back to the structure drawing for a second. Like I mentioned, the structure that you're looking at in this drawing has been created using the Plant 3D structure tool. So these tools are available in the ribbon menu right here under the structure tab. And these are the tools I can use to start placing some basic structure in my plant 3D drawings. In addition to that, I also have some modification tools and cutting and manipulation tools that I can use to make some adjustments as and when required. Since Plant 3D is primarily a process piping design software, so even though you can draw some basic structure in Plant 3D drawings, but you cannot do structure detailing. With that being said, we do have a tool available in the ribbon menus in Plant 3D that can be used to export the Plant 3D structure to advanced steel. So I'm going to click on that tool, and I'm going to define the location of the output file. Let's save this file on the desktop, and you can see that you're actually exporting the Plant 3D structure to a .smlx file format, which is a file format that can be brought into advanced steel. So let me type the name of this file. And after that, I will select all the objects, and I will use the AutoCAD selection window to select all the objects. Click export. And now I have a file available in .smlx file format, which I said is ready to be imported into advanced steel. And at this point in the webinar, I would like to give the control to my colleague Hung, who is going to show you how you can import that file into advanced steel, and then he's going to walk you through some different features in the advanced steel software. So over to you, Hung.
Thank you, Junaid. Hi, everyone. My name is Hung. I'm with SolidCAD for a few years now and take care of the advanced steel robot structure, Revit, and on that line of work. To quickly show, just state what we like to demo for today. So the aim is to take the file that is sent to me from Junaid, and my job is to continue add on the detail and show you some feature of how to create ladder and connection in advanced steel, railing, and on the detailed connection, how can be quickly create in advanced steel. And plus, compared with other products, let's say pick up Inventor, for example, then you could do a very fast 3D model, but then when you go to generate detail for shop, for fabrication, you still have to go and select every single part to generate drawing. And where in advanced steel, with one click button up here, let's say that we call the drawing process. After you've done that, then you quickly have all of the drawing completely done for you in the background, and then we're done. It's very detailed. It put in your title block. It put a partlet build material and everything ultimately with dimension, and the time for you to do on the dimensioning like this, it will take forever. With advanced steel on the actually do ultimately for you. With that in mind, let me just quickly show you how I start doing this. So receive the file from Janelle. I just go in advanced steel and start with a template, and from that I can go to export and import my advanced steel and take the structure SMLX from Janelle to coming over. Ultimately, you'll see everything that's come in very smoothly. So I will go ahead just to quickly hide a couple of objects and display some of the object that it come from the file that Janelle sent it to me. Advanced Steel famous for its connection. So in here, just quickly show you how I can use one of those connection macro. So just select the two objects. Ultimately, Advanced Steel will bring you a macro of a knee frame, for example. Let's repeat that on the other end. So it instantly add on of that for you. And more than that, for example, on the base, I add a base plate to one of the column. And once you have the column configured, for example, on my screen right here, you can save it in the library. So whatever you need to assign the configuration will come in right away. And let's say you have multiple thousands of column, what can you do? You can just select the one and propagate it. So all of the will automatically multiply to another column right away. You don't have to go at the one at the time. And let me just show you another connection. For example, repeat that on the library. I just select two objects to add in the shear plate connection. And you see over time, I have a few configuration for the connection created and save it in the library. So all I need to do is assign them that way. Together with the propagation, multiply the connection, advanced still come with a very more wonderful feature. For example, I can just select one column and want to expand it to on the rest of the condition. They copy them and it automatically group them, and it does all of that job for me. So let me just illustrate one more time. I just add in a angle, for example, that between the column and the beam. And under library here, I have a few configurations, but none of them actually work for me. It doesn't make sense to put in a clip angle that way. So how I'm going to remove the connection? I just simply select one object on the connection and just erase it. The curve and everything removed for me. So if I want to do this again with the correct one, I just select the column and the beam, and right away I have all of the connection that again that is saved in the library. Now I can use it. Carry on, just repeat that. I want to populate that corner of the connection to the other three column and the other two vertical beam right there, and it automatically group it for me. And so the group here means whenever I change the master, the rest of it will update. So I don't have to go on each individual one to update them. So that is the quick about connection. Beside that, you can also have ladder, stair, and staircase and railing. So I just move the UCF to the side to the position right there and swing the Y direction to the right hand side just to show you how quickly we can create a case ladder, for example. So issue the case ladders command, and I start from that point. I just go up randomly, certain height doesn't matter because the whole system is parametric, so you can change it anytime you want. So the case ladder, very intensive configuration right there. And again, when you've done that, you just simply save it in the library. So I have multiple K that done in the past. I select the ASC one, for example. In here, it actually go up to 16 feet, and it have on the flat bar. Now, change my mind. I want to go to 11 feet, and then go to a rail step instead of a flat bar, and you see it automatically have a skirt on the case, and it connect properly to the beam right away for me. So that is the ladder. So let's just play along with the railing, for example. So I want to have the railing to go around the 4 beam. So I just select them and just verify where the railing going to start and where the railing going to end. So we get the nearest, yeah, to the other end. So after I verify 2 points, just hit and enter. Advance to automatically have the railing layout correctly there for me. But there's a real problem right there because it doesn't go all the way around and it know how to stop. So again, the railing have all kind of feature that it allow you to verify changing them. So I take some time and create one configuration with no end. There's no loop end on the right hand side. So you see it automatically remove the loop end on that end. So now suppose that I have another railing that it go from on that beam, and I'm going to start it from the neck to the case and to anywhere along that beam to the right. Similar, if I hit enter, then I will automatically have that configuration. Now I'm going to change the other end to the same thing that I configured earlier, and it's very straightforward, easy to do. And now how are we going to connect the two corners together? Advanced Steel quite clever. It have own other connection, for example, for railing. So all you need to do is select the two tube to the top right there, automatically miter them. It's just like fillet with zero radius. But I'm gonna change that to knee instead of miter. So you see it rounded up and we connect the two things together. Let's repeat it one more time. Select the first tube, select the second tube, and hit enter and go to the handrail fitting and change to knees, and you have it completely done that way. So how gonna resize the handrail to the proper position? You see, when you put into two handrail, it have a two dot in there, and it's very clever. So I like the handrail to move and lengthen it closer to the cage, so that that no gap in between. All you need to do is pick those two dots on the handrail and drag them. I drag it backward to the left, so it will not jam into the case of the ladder. So I just simply manipulate, or if you like, you can do an exact number on it. So to configure it that way. So now every connection, it comes with a proper layer. So if I just want to turn on the connection box off on the layer, and then it's cleaner. So now if I turn to conceptual, you see that I actually now I can remove and show the plate that it come from Plan 3D. But there's a problem. How can I remove all of the connection there? And with Advanced Steel, I have a tool that allow me to cut and remove every connection, so it clears out for me right away by 2 clicks. Just select the place and another connection on the handrail, and it remove that for me. It's hard to see, so I just turn it to wireframe, so it's easy to select that one and select the place of the connection and couple clicks, and now it cleaned out everything. So all of these this step at the detailer, that where you need to go around and clean them up, and after that save the model. And when the model is saved, you just simply hit this button, then it will generate all of the drawing and it's stored underneath the folder, and it will understand that on the 10 where all of the object with the anything welded to it, it will turn that into assembly for you, and every piece and part of plate or water in the model, it will turn into a proper drawing, and it put in the dimension, everything for you. And you could use your own part block, and whatever you modify to the model, all of the drawing will automatically update. And if you want to force it to update with the revision, and it automatically add the revision for you. So I think that's good enough for my side. So I actually saved it model, send it back to Junaid, and Junaid can continue with the workflow of merging Advanced Steel with Plan 3D. Junaid, could you please take it over?
Sure, thank you, Hung. Give me a moment. I'm going to share my screen. Right. So I have received the file from Hung coming from Advanced Steel, and I'm going to bring that file into my Plant 3D project, and I'm going to use that as a reference to start placing my components. I would like to mention a couple of important things here. First of all, obviously, you would like to show the Advanced Steel structure in the Plant 3D orthographic drawing. So if that's the case, we recommend that you copy the Advanced Steel file into your project. So I'm going to create a new folder, And I'm going to copy the advanced steel file into this folder. That's the file. And it's going to take just a few seconds to copy. Once the file is copied, I'm going to open up the file, and we can take a look at this file. And this is the file that I said is coming from Advanced Steel, which is prepared by my colleague Hunt. And you can see that this file is much more detailed as compared to the structure that you can create in Plant 3D with a lot of information. All right, let's save and close. And I would first of all go to the equipment drawing, because in my equipment drawing I still have the reference to the Plant 3D structure file, which I would like to remove now, and I would attach the advanced steel file. So I'll go to the external references, detach the Plant 3D structure file. After that, I'm going to attach the advanced steel file, which I can do from the right-click menu options in the project manager. So the advanced steel structure file has been referenced into my equipment drawing, and I'm going to spend the next few seconds placing a new equipment. So I'm going to go to Home tab, and I'll click on the buttons available in the Plant 3D software to place the equipment, and I'll select one of the subtypes for the pump, and I'll define a tag number. And this is the equipment which is coming from the Plant 3D equipment library. And I'm going to type the values of X, Y, Z coordinates. The equipment is drawn, and when I hover my cursor on the equipment, it shows me the tag number is P-100A. Since Plant 3D is AutoCAD based, so I can use the AutoCAD copy command to make a copy of this pump. And I have a copy of this pump, but if I hover my cursor on this pump, it says the tag number is P-100A question mark. So that question mark indicates that the tag needs to be changed, because you cannot have duplicates in Plant 3D project. So I'll assign a unique tag. Tag is assigned, everything is good, and I will now save the drawing and close the drawing. Next, I will go to the piping drawing, which is where I would like to attach my equipment drawing and advanced steel structure file both, and I will use them as a reference to start placing my pipe runs and pipe supports. And again, I can attach those files using the right-click menu options. Advanced steel structure file is attached, and I'm going to attach the Plant 3D equipment drawing as well, and that's also attached. Okay. For the next couple of minutes, I will draw a couple of new pipe runs, because we want to see everything inside the orthographic drawing and in the isometric drawing as well. So I'm thinking to draw a pipe run connecting from this nozzle, which is 6 inches. So I'm going to select the size from the ribbon menus, click on the tool, and snap to the node of that nozzle. And I'm going to change the plane to define a vertical drop, and I'll type the length 6 feet. I'll do a little bit of rotation to make the view a bit more better, and change the plane once again, define the length. And here I also can use the auto routing feature in Plant 3D, where you can snap to the node of a nozzle and click, and program shows you a possible routing from that point to the nozzle. I'm going to accept the next placement, and this is how the pipe is drawn. And then I also can select the pipe run and use this plus sign grip to place another pipe run here. And not only that, but I also can click on the T's to substitute them with a different size available in my spec. And after that, if I want, I can use the properties window to change the size of the pipe from 6 to, let's say, 4. Okay. And then I would place some inline fittings, and I'm going to go to my tool palettes, which is docked to the right side of the screen. And I'll select a valve, and I'll draw that valve on this pipe. Define the rotation of the hand wheel, and I'll place another globe valve on this pipe run as well. And you can see that the program automatically adjusts the size according to the size of the pipe run. I didn't have to do that manually. And I'm going to draw a couple more valves. by defining the locations and the rotations of the hand wheel. And if I want, I can go ahead and assign the tag numbers to all these valves and assign the properties in the properties window. I would also like to place a couple components and a quick pipe run here. So I'll define the starting as the nozzle on this pump, and I will change the size to 4 inches because I see that nozzle is 4 inches. And I'm going to click on the check valve, place the check valve in my drawing, one on each pump. And then I will click on this check valve and use the plus sign grip to draw a pipe run, but I also can right click and select one of the fittings. So I'm thinking to select a gate valve, double disc, raised face. When I'm placing it, I can also right click and say fitting to fitting connection, and program is going to allow me to do a fitting to fitting connection. I can carry on drawing the pipe run, 8 feet, and a little bit of auto routing here as well. So I'm going to snap to the node of the nozzle on this heat exchanger and select the first placement. After that, I'll do the similar steps on this check valve as well. So just a click on the plus sign grip, right click, pipe fitting, select the same gate valve, which is double disc raised face, right click, fitting to fitting, and I will connect that pipe to this pipe above, and program is automatically going to insert the T. I'm thinking to make a slight change to the elevation, which I can do dynamically by having the AutoCAD dynamic input feature on. And I'm going to click on this tool, this pipe, and I'll use the tab key to change the keyboard focus to the bottom of pipe, BOP, and I will change the elevation based on that. And in the end, I will place the pipe supports. So I'm going to go to the supports spec, add pipe support button, and I'm going to define the filter to select this support and place it on the pipe. I'm just eyeballing, but if I change the view using the navigation cube, I also can make some adjustments a bit more precisely, using the AutoCAD snapping options. I also can use the grips available on the support, so to change the geometry of the support. I'm pretty much done with my model. So in the end, I would like to quickly assign a line number to this pipe run, because I would like to assign I would like to use that line number to create the ISO drawing. So say the line number is, for example, 1000. Okay. After that, I'll go to the ISOs tab, use the production ISO tool, select the line number, select one of the ISO styles available, click create, and program is going to process the ISO in the background. While it's processing the ISO in the background, you can carry on working on your model by zooming in and zooming out. The program is going to process all the information in the background, and it depends on how much of information the program is processing. So time could be a little bit more, a little bit less. But as soon as the ISO is processed, you'll get a notification in the lower right corner, which will say that the ISO has been processed, and you can then look at the ISO and all of your bill of materials and all the other information that you're looking at will also be there on the isometric drawings. It's right there. So this is the isometric drawing showing you the weld list and the cut piece list and the bill of material table. Then the output of the ISO can be customized according to your project needs and requirements. Let's quickly go to the orthographic drawing, because we all want to see how the advanced steel structure is going to show up on the orthographic drawing. So generate the orthographic drawing, and the software shows me my model in an ortho cube. And in this ortho cube, I can first of all make sure that I select the advanced steel file. So I'm going to select the advanced steel file from here. I'll select the equipment drawing. Piping is already selected, and you can see I'm not selecting the plant 3D structure, just the advanced steel structure. Click OK. The program does a refresh, and I'll use the navigation cube to make some adjustment to the length, width, and height of the cube, just so we make sure that everything shows up on the viewport. And I'm going to make some adjustment to the ortho cube here on this side as well. Okay. And I'm thinking to create the orthographic drawing from the back, which is on that side. Let me actually use the navigation cube to go to back. And from here, I can use one of the scales to the scaling. I can assign a scale to this viewport. Click on the paper check. If it appears that if it's a bit too big, you also can make it small by using the scaling options. You can define if you want to see the hidden line piping or not. Click OK, and then you can generate the viewport on the orthographic drawing. And once the 2D projection is created, you'll see that it shows you the advanced steel structure on the orthographic drawings. And you can now use the Plant 3D annotation styles to start annotating components. In addition to that, if you want to add some extra info using just the text tool, so you have the text tool and the dimension tools available on the top. If you want to create the reports in an output file format, you also can go to the report creator tool and use one of the report templates available to generate the reports in an external file format, for example, an Excel file, which is going to show you a list of all the 3D parts. Okay. So once that Excel file is generated, you will see that it shows you all of your 3D parts with the Autodesk logo, because we are using the default report template, and you can totally customize it to have your own company's logo and everything. This is pretty much it. This brings me to the end of the webinar. I know some of you have asked questions, but we have run out of time. Like I said, we'll still be getting in touch through emails with all those who ask questions and try our best to answer your questions. Meanwhile, if you come across any further questions or concerns about the products, please do not hesitate to reach out. If you need some further information about the products, we're just a phone call or an email away. Our contact detail is displayed in front of you on your screens. Once again, I would like to thank you all for registering and attending, and we look forward to hearing from you. Goodbye.
Thank you everyone for joining. We will be in touch soon.